You don't have to adjust. You're flying at a constant altitude above the Earth.
Do you adjust nose down around the globe every minute when you fly at 500 miles per hour?
No.
We do not need to nose down at all.
Does the aircraft ever need to dip its nose down to account for curvature?
No.
In straight and level flight, stick a bowling ball down the aisle. It will roll to the back of the plane. That's because the plane in level flight actually flies about 2 degrees nose up. Yeah, it's pitch attitude, but yeah.
Maintains rigidity in space, right? So if you were to tilt the plane up, down, roll, it would show up on the attitude indicator, right? Okay. So if you were to fly from the North Pole, or, to say Australia to the south under here, will your attitude indicator be upside down?
No, we wouldn't.
Welcome to Flat Earth. Do you adjust nose down around the globe every minute when you fly at 500 miles per hour?
No.
Okay, how often do you have to adjust for the curvature of the Earth?
You don't have to adjust. You're flying at a constant altitude above the Earth.
If you maintain the altitude around the globe, is this line curved?
Yeah.
You said you don't need to dip the nose down to account for curvature. You maintain the same altitude around the globe. Is this line curved?
The line curves because we're taking into consideration the curvature of the Earth. We do not need to nose down at all.
Does the aircraft ever need to dip its nose down to account for curvature?
No.
Now, this is the globe model. This is the correct dimensions of the globe. Now, I'm going to start the flight. It's going to take off. I'm going to set pressure level, so maintain the same altitude. Now I'm going to make the reference frame the Earth, so that the Earth is the reference frame. And now we're going to see what happens. Now, the plane is not going to nose down. It's not going to change orientation. And I'm going to include gravity. And when I include gravity, you'll see that it activates pendulous vanes as well. But now what's going to happen is the plane's going to end up just facing away from the Earth, because we're not changing the plane's orientation, right? We're not nosing down. We're not changing altitude. And yet the plane's just going to continue to pitch up and up and up. Now, the Earth is constantly curving down and away from the plane. We would need to adjust for that, right? We need to actually stop that from happening by lowering the plane back down, right? As you can see on the attitude indicator, it's gaining more and more pitch, more and more and more. And if I put autopilot on, it'll start automatically nosing down, and that would immediately show up on the pitch graph. But the pilots admitted that they don't need to ever do that. If we had to fly from the North Pole to the equator, well, we've got major problems, because the plane's just going to continue to face away from the Earth. I need to nose down. I need to. Because now I have to fly really, really slow, right? Otherwise the plane's just going to take off. So you can see it wants to fight gravity. It wants to fly away from the Earth. So I have to stop that, either by throttling down or nosing down. Yeah, I mean, the pitch hasn't changed. The altitude's all over the place. And I need to change the pitch, so I need to nose down. Otherwise, I'll fly off the Earth. So there you go. Now you can see on the pitch, I'm nosing down, and we're flying. Now I'm going to throttle up. Now I'm going to try and maintain an altitude of 2 degrees nose up and about 35,000 feet, as you can see here. Up, need to nose down. Up, need to nose down. And up, need to nose down. And up, need to nose down. So, I mean, this is not what happens in reality, guys. Now I'm going to start it again on a flat Earth model. And I'm going to compare it to the pitch graph, the real pitch data that we have in reality. Now, I'm going to fly over the Earth. And look, it took a big spike to take off, leveled off, 2 degrees nose up, altitude is the same. So now, if I trim it and then speed it up, so now it's, how much sped up is it? It's 150 times sped up, and you can see that if we fly, say, 15 degrees there, and then 15 degrees here, it's just going to maintain that same altitude above the Earth with a pitch up. And then I'm going to come into land and the nose up. There we go. So we landed with the nose up because the horizon and Earth is still parallel to the plane. So this proves without a doubt that the plane would have to follow the curvature of the Earth down and away as the Earth curves down and away from the plane. But in reality, that doesn't happen. That's why all the pilots admit they don't need to adjust for curvature, don't need to nose down.
You don't have to adjust. You fly at a constant altitude above the Earth.
Do you adjust nose down around the globe every minute when you fly at 500 miles per hour?
No.
We do not need to nose down at all.
Does the aircraft ever need to tip its nose down to account for curvature?
No.
You start off at the North Pole like this. Okay? See, here's the North Pole. Here's my airplane. It's a set height above the ground. When I come over here,